We're all good. All right. Looks like we're live. Thanks, Monica. So wanted to say good morning to everybody. Thank you for joining us. My name is Nikki Cabus. I'm the VP of Development for Palm Beach Tech. To give everybody a little overview of what Palm Beach Tech is, we are basically a tech nonprofit. We started just about 5 years ago. We're about to have our 5th anniversary party next week on the 29th. I'll drop the link for that in the Zoom chat for anybody that's interested. And basically, our whole goal and mission is to build South Florida into a tech hub. So we work with a lot of the headquartered companies here, of course, the local tech talent, our colleges, universities, and coding schools like we have on this morning, and making sure that we're just connecting all the dots, bringing all the people together in our tech community. Everything from, like what we're doing today, introductory, like coding classes and intros to things to get people kind of upskilled and ideas shared, to we have different panel discussions, tech talks. So there's a lot of ways to get involved, connect, and learn. And I want to introduce this morning our speakers. We actually have Lindsay and Rafael. Lindsay, I want to introduce her because she'll be able to tell you guys a little bit more about Flatiron and about the discussion this morning, and then introduce our actual instructor, Rafael, for us. So Lindsay, if you'd like to take it away.
Awesome. Yeah, thank you, Nikki. My name is Lindsay. I work on the marketing team at Flatiron School, which for those that don't know, Flatiron School is a software engineering, data science, and cybersecurity bootcamp. So we take students through 12 up to 15 months of bootcamp education, specializing in software engineering, data science, or cybersecurity. And we help our students learn the tech skills they need to ultimately land a job. So we have awesome instructors like Rafael here today. He's one of our lead online data science instructors who teach our students the tech skills they need to land that job once they graduate. We also have career coaches and educational coaches that help our students learn the skills they need to land that job. I'll hand it over to Rafael to get started, but if anyone has any questions about Flatiron School, let me know.
Yeah, awesome. Good morning, everyone. How are you? I'm Rafael. Like I said, I am an instructor at Flatiron for our data science, our curriculum there. It's been awesome. I love it. I was one of the first online instructors and have been there ever since. And it's been an awesome place to be. Yeah, so I just wanted to talk today about some data science basics. I'll go ahead and share my screen. Kind of takes me a minute to get my feet completely settled after that, but just give me 1 second. Let me move everyone's faces over here. And if you can, I would love it if you could put your camera on, if that's possible, just because it's great whenever I can see faces as I talk to people. Otherwise, I feel like I'm just talking into the void, which, but if you can't, that's also fine. So I will be doing this in Jupyter Notebook, which I'll talk about what that is in a little bit. So if I do have to exit this slide view, just please be okay with that. But anyways, so just a little bit about me. I do have a master's in both mathematics and education, but more importantly, just like some hobbies of mine, I like to cook. I'm like a huge fan of cooking, especially lately with COVID. I've been cooking a lot more at home, which is really good. I love puns. I think being a mathematician, we say a lot of puns that nobody really appreciates, unfortunately. That's okay. I love memes. So when I tell my students, if you ever want to win me over in presentations, just put a meme in there and I will like gold. I love good memes, GIFs. My favorite shows are Queer Eye, and then I also watch MMA. If you've never seen Queer Eye, highly recommend it. You will probably ugly cry on any episode that you choose, but it is just...
Those are like the same thing, right? Queer Eye and MMA?
Yeah, exactly.
Basically the same thing, right?
Yeah, exactly. No, I love Queer Eye. I could talk about either one of those two things for a while. But anyways, that's just a little bit about me. If you do have questions about anything I'm saying, please put it in the chat, and I will try to be checking that as much as possible. And we'll just get started, huh? So what is this field of data science? I think it's like, it is somewhat ambiguous, and many companies have many different definitions for what their data scientists do. And I think that's really important because if you've ever looked, like who here has ever done a Google search for jobs in data science? Anyone like looked through job descriptions? They're all different, right? They're all completely different. And I think that's really, really important to state because it is a very new field. It's kind of like being a doctor in the 1500s, right? You did everything. And that's kind of what it is now. It's starting to get more specialized where we're seeing some data scientists go into big data or natural language or bio data or ag tech or fintech. But honestly, a lot of it is very vague. The big things though are you need to know computer science, right? You have to know how to code in some language. We'll talk about languages in a little bit. You also need to know mathematics and statistics because most of what you're doing in data science is you're not like building as many models as you think. I think people think, oh my God, I get to build AI. It's like, no, you're actually just messing with data the entire time. And to do that well, you have to know math and statistics. It is, and that is a lot of what we teach here at Flatiron, is the computer science and mathematics and statistics. And then the other thing is you need to have like domain expertise, which that comes with experience, right? You don't, unless you of course are transitioning from a specific field like finance into being a financial a data scientist, where then you can use your domain knowledge. So a lot of what you're doing is you're collaborating with other people who have domain expertise to give you ideas on how to play with your data and make it really good. But these are kind of like the three big components of being a data scientist. There are obviously many more. I think one of them is being really creative, but you don't get that until you become really proficient in your domain and your mathematics and statistics and your computer science. So the top languages of data science right now, I just looked this up, the sources here, but they are Python, R, Java, and C or C++. There are more languages. Scala is becoming really popular. Kotlin is not becoming as popular as I think it should be, but it's a really good language for data science. It's kind of developed for data science, which is really cool. And then of course there's things like TensorFlow, which I'm sure if you've looked at data science, you've heard of that. Go is another language. There's a ton of languages out there. Just because I say a language does not mean I know it. I just know of it. So just please keep that in mind as well. I don't want anyone to think I know like a million computer languages. So today we're going to be doing things in Python and just some tools that we use a lot in Python. I'm going to go ahead and use my annotation tool. This is the big one. I think NumPy is one of the most underutilized libraries. I think people really love to hop into scikit, and by myself as well, I'm guilty of this. I think people just hop to like scikit-learn, and really like when you're doing things in a production environment, sometimes your servers need to run things really fast, and NumPy is like the best library for that. There's also things like TensorFlow, and then for visualizations, you can do things with Matplotlib. Gensim is really good for natural language. Keras, which is this symbol, is really great for building deep learning networks. So convolutional neural networks, multi-layer perceptron networks, anything like that. But these are a lot of tools that you start using as you get into data science. And we're going to be using today some of these tools. And yeah, are there any questions so far over anything that I've said? Mm-hmm. Please ask. That's why we're here. So, and like I said, if you do have one, just type it there. Okay. So a couple of more tools that weren't listed that we will be using is pandas. Has anyone heard of pandas before? Yeah, just show of hands or something. So pandas is a library where it helps you interact with data. So you can have like a CSV file or a JSON file or some kind of a file that that just contains data. Pandas is the library that helps you manipulate the data, play with the data, do stuff to the data that you need to yeah. Yeah. And there's actually a new library for big data called Koalas, which is a play on pandas also. So that's a fun fact. There's also Seaborn, which we'll be using, which is great for visualizations. And then there's Plotly, which is amazing for visualizations. It's a little bit more complex to use, but it's worth it if you can learn. Okay, so when you're doing a data science project, right, someone hands you data and they say, hey, I need you to go and investigate this problem. This is a good workflow that I use a lot. It's called CRISP DM. It's a suggested workflow that we try and use as much as possible. The first thing that CRISP DM, whenever you use this workflow, is like the business understanding, right? Why am I solving this problem? What are we doing with this problem? How can we use this problem to help our business, to help a business? That should be like the first thing that you know. If you don't have that, it's really hard to find direction whenever you're going through your data, because it can meander off into various pathways that may not be the most useful way to spend your time. So I feel like knowing what you're doing and why you're doing it is important. And then after that, the data understanding. What data do I have, and do I understand what the data is saying, right? Like, what do the columns mean? What do the numbers mean? What am I predicting? What does that mean? What's the scale of the data? Like, very fundamental things that should not be skipped, but often do, because people get really excited and just want to start playing with data, which is completely understandable. And then after that, I would say you spend the most time in the land of data preparation, cleaning your data. That's like 80% of what you do is preparing data for modeling. It is just a vast amount of the work, because your model is only as good as the data that you put into it. So you have to get your data conditioned well to feed it into your model. And you'll see an example of that here in a little bit. Then you have to evaluate your model. After you evaluate your model, you kind of check, like, can we even answer the question we want to answer, right? Like, you go back and see, like, is this viable, right? And then if it's not, you need to change what you're doing, why you're doing it. And then you just kind of go iterate through this process until your model quality is where it's at and you're succeeding in the business goal that like you had in mind. So let's say you're trying to recommend videos that people will actually click on, right, in YouTube. Well, you need to make sure that you, one, can do that, and two, you need to check that, like, that's actually happening with an algorithm that you put in place. So, and then once you've done that, you can deploy it to users. And then this goes through beta testing and other things like that, which we're not going to get into today. So are there any questions about this workflow? Awesome. So right now, I just want, if you can, just put into the chat like something that you know about data science that got you interested, just because I want to see where we're all at before I begin just putting a bunch of stuff in front of your face again. So I think what got me interested in data science was just hearing about TensorFlow and the AI bot that won Go, which was like a big deal because Go is like one of the most complex games that you can play. I don't know if anyone else got interested in data science through that, but that's kind of what got me into it. So yeah, if you could share that with me, I'd love to see it, and it just helps me see why you're here, and we'll move forward. So what you do as a data scientist, and like I said, these are based on my experiences. 70% of what you're doing is conditioning your data. And I put this garbage in and garbage out metaphor. This is something that we use a lot. If you pass in bad data into a model, I don't care what model you have, if your data's not conditioned well, it's not going to be a good model. That's just usually the way it works. So that's honestly most of the time you're conditioning data. 20% of the time you're experimenting, and then 10% of the time you're actually communicating what you're doing to people who need to know about it. And you need to communicate that in a very non-technical way, or a technical way depending on your audience. Ooh, got some answers here. Doing data analysis on Earth science. Ooh, yeah. I would assume NASA data is very interesting. I don't know, I've never worked with it, but I can't imagine the amount of data that NASA has. Market trends, that's a really good one. You could definitely build things to do that. Sports analysis, way out of the realm of things, but I know a lot of students are interested in it. Yeah. So this is what you're doing as a data scientist most of the time. Like I said, it's all about conditioning the data. So what we're going to be doing today is, and I have to kind of exit here just to give you a better view, but we're going to be using some of these libraries, and I'm going to be reading in this housing data set here. And this housing data set, if you look at it, it's just a CSV file, and you can load it in with pandas. And so the benefit is we took a CSV file that looks like this, right? And if you've ever read in files and code, who's ever done that? Just a show of hands or something. Yeah. Imagine building a parser to organize and structure this data. That's a pain, right? So the great thing about pandas is it's got a built-in read CSV function that just takes in a CSV and automatically applies structure to it, which is like, I mean, it's such a gift, honestly. And it gives you the columns. And so what we're going to try and do is use these features about a home to predict the price of the home. That's the goal. So let me see if I can go back to the slide mode real quick. Let me go back. So if we look at our columns here, we have the ID of the home, which is not super important. We have dates that they were sold, which we could use. I'm not going to use them right now. We have the prices of the homes, the number of bedrooms, number of bathrooms, how big is the square foot living area, how big is the lot, the number of floors, is it by the waterfront, what's the view, et cetera, et cetera, et cetera. All of these different features. We have some location data, and then we have square foot living 15, which is like the average square footage of 15 homes near it, I believe, and square foot lot 15 is the same thing for the lot. So are there any questions about this data set? Yeah, so that's what we're going to be doing. I'm going to kind of walk you through how I would do this problem, and you'll just see the workflow, and I think that'll be hopefully very beneficial. And if you have any questions or ideas, like, hey, look into this, I'm really curious, let me know. Okay, so like I said, the goal, we want to use this data set to make a model that predicts the prices of homes in Kings County. So the first thing we need to do is understand the data, right? We need to clean our data, we need to explore it, we need to condition it, and then feature engineering, which I haven't really touched on, but you'll see what that is like at the end. I might touch on that if we have time. So the first thing that we do whenever we clean data is we check for null values. A really easy way to check for null values is just to do df isnad.sum, and this will literally just look at each column and find null values in it. I mean, it's super simple, and I got to go back to the notebook view, unfortunately. So if we look here, we have 2,300 null values in waterfront, 63 in view, and 3,800 in year renovated. So the first thing we need to do is like figure out how to handle these null values, because it's different for every column, right? Waterfront means, is it by the water or not? And one of the first things I do whenever I start handling null values is I just want to see the data. And so I just plotted a histogram of the waterfront. And what do we notice about this histogram? So first of all, what does a 0 mean in the waterfront column?
No waterfront.
Yeah, it's not by the waterfront, and a 1 means that it is by the waterfront, right? So what do we notice about this histogram? Anyone?
Most properties are not by waterfront.
Yeah, they're almost all 0, right? Which makes sense, right? Almost no one lives by the water. They're probably more expensive. So another thing that I like to do is I like to look at the actual value counts. So you can do that using the .value counts function, and you can actually call the waterfront column almost like a hash map. If you've ever worked in Java or JavaScript and you use like hash maps and stuff, um, you can get the whole column and do a value count on it, and it'll show you how many zeros, how many ones, and how many null values you have. 19,000 zeros. That's a lot. So, especially out of the 23,000 or 21,000 columns that we actually have. So, what I decided to do, and this is just my decision, I'm just going to safely assume that if it's a null value, it's a zero. I'm just going to replace every null value in there with a zero. Is this the best thing to do? Maybe, maybe not, right? You have to try and experiment and see how it goes. Maybe you want to see where the house is at using latitude and longitude, and maybe use a better way of replacing this value. I'm doing kind of a blanket, just let's just call it a zero, which may not be the best approach. So when I do that and I recheck it, now my waterfront values are all filled in, right? There are no more null values. So the next thing is looking at year renovated, because that's got a lot. It's got 3,800. And if I look here, most of my year renovated values are zero. Are most houses renovated? Maybe. I don't actually know. This would be where I like call someone who knows more about houses, but the fact that they're more zero, or most of them are zeros, I would just honestly, I just dropped the column. I was like, if the most of them are zero, this is probably not going to give me a lot of signal that's going to be very important. Do you have to do that? Absolutely not. Do whatever you want, right? There's a lot of approaches to like handle data. And the next thing is view. And I just dropped view because most of them are zero as well. And so that's why I did that. And now, boom, we have no more null values. So at this point, we haven't cleaned the data. We've cleaned part of it. We haven't finished, but all we did was really remove null values and kind of handle those. The next thing we need to do are look at weird stuff in data, right? If people are manually inputting data, you're going to get all sorts of weird things in it. And that's really important that you know it. That's why things like form stack are really helpful. Anytime you can put a form in a website, that can maintain your data integrity, right? So if people are manually putting in data, you get a lot of nasty stuff. And one thing that's cool about pandas is it has this .info function, which shows you like a breakdown of all the columns. And so anytime you see the word object, it's basically referring to something that's just not a number. And it could be a string type, it could be a dictionary in Python, or a hash map in other languages. It could be anything else, but we have one and it's under square foot basement, which is weird. And so I went ahead and looked at square foot basement, and I found that we had these weird question marks in it. So the next thing that you would need to do is get rid of them, and I just replaced them with zeros. And then after that, I converted them to floats. So we end up getting our square foot basement as a float. I'm gonna go ahead and do that real quick, make sure I do that. Okay, so we have then made, so now they're all numerical. So if I do a df.info again, I'm gonna go do that. Get all this right here. All right, so are there any questions so far before I begin doing visualization stuff? Any questions, comments, cool things, not cool things? All right, cool. If you have anything, just let me know. So then after this, after you clean your data, and let's just assume we've cleaned the data, everything's the way we want it. That's not the case, but let's just assume it. We would jump into EDA. Best practices with EDA, I always use scatter matrices, but they're really memory intensive, and you'll see what one is here in a little bit. But then you also want to make visualizations that actually communicate information. For the people here who are used to working with people who make business decisions, they will probably attest to how important that is, right? Visualization should say something. They shouldn't just be pretty. They should actually communicate sometimes your bar chart's the best thing to do. Like, it's basic, but it just gets the point across. And that's why we use them. So that's really important. So we're going to move to a scatter matrix. And in pandas, you can build one pretty easily, but it's super big and it looks kind of messy. So if you have like 50 columns of data, it's gonna be horrible. Luckily, there's only 20 something columns, so this isn't too bad. But let's just kind of explain what this is. So what a scatter matrix is, it's literally a matrix where the diagonals are all histograms of each column. So this diagonal is a histogram of the IDs, which isn't really important. This diagonal is a histogram of the price. This diagonal is a histogram of the bedrooms. This one is bathrooms. This one is square foot living. This one's square foot lot. And then anything that's in the off diagonal is a scatter plot. So this is price versus the bathrooms. And you can kind of start reading it. Now, do I go individually and look at all of these? No. One thing I do is I just start looking at things that are, things that I find interesting about this. So does anyone see any graph that just looks interesting to them?
Yeah, the one that's I think it's something square feet above. Yeah, and then 2, 4, like the fifth one there.
This one?
That looks highly that looks highly correlated.
Yeah, we have a lot of correlation here, definitely.
And then there's also square foot living. If you go up about 5 or 6, and then like about 2/3 of the way down, there's another really highly correlated one.
Oh yeah, these. Well, honestly, like all three of these have a lot of correlation. Yeah. Then there's some correlation here. Yeah, this one's got some. It's got like a trend, but we have like weird outlier values as well, which I think are important to notice. So this is why I like scatter matrices. I feel like they point me in good directions to just start, right? They're not going to give you a lot of details just because they're so, like, it's just a lot, but I just use it to start looking and finding patterns. And that's really it. So are there any questions about this? Anything? And you can change the color of this as well. All that's in the code. So if you do have people who you work with that are colorblind, you can just put in colors that are colorblind friendly. You have lists of tables, and then they have color palettes of them as well. All right, let's start visualizing our data. I couldn't find a good meme, but I wanted to, and I wanted y'all to know that I looked. So I think that's important. I looked for a meme up and down for data visualizations. None of them spoke to me, and I didn't want to use it. So your best friend is a histogram. Has anyone ever heard that before? Like when they talk to a data scientist, like histograms, as basic as they are your best friends. That's 100% true. So let's just look at the price. Before we do anything, let's understand our home prices. And what do we notice about this price distribution? Well, it's heavily skewed, right? Most of the data is over here, and then we have some outliers. So at this point, you could start making a decision like, do I just remove all of that data and just get rid of it because they're outliers? You could. You're 100% okay to do that. I'm not going to in this example, but like honestly, there's not a lot of data here, and outliers can really mess up models. Like you don't want them. You want to investigate them, but you don't want to put them in a model because they throw off the predictability of the model.
Can you change your binning so that you know it's like more logarithmic or something?
Yeah, so I did 40. Oh, do you mean the scale?
Yeah.
Yeah, so like you could do a log transform on it like that, and you could look at it through like a log transformation, as well as just changing the number of bins that you have. But I don't like to log transform the thing I'm predicting because I want to I want to keep the scale the same, and log transforming changes the scale. And, you know, if we predict a housing price, like, let me put it back in log terms. What does a 13 mean in terms of housing price? Right? That is mean. If you told your manager that, hey, I predicted a 13, they'd be like, well, what are you doing? Yeah, like, I need dollars, right? We're like working with money here. And so, and also error means something completely different in a log scale. If you're off by a half, that's actually a lot, depending on what number you're off by a half on. And so I'll have students who do this, and then they're like, oh my God, this is so close. And then we untransform it, and then it's like millions off. And that's just because it's a log scale. So I don't like to log. You can log transform other things, typically not the thing you're predicting. Okay, so aside from using, and this is using matplotlib, you can also use Seaborn. Seaborn's really nice, and you can plot, like, it's called a categorical plot. And so what's cool about Seaborn is you can just pass in the data frame that you're using, which is df, and you just give it column names. And then you tell it the kind of thing that you want to plot, and it makes it. Like, Seaborn's great. So this is a strip plot, which is really good because it kind of shows you density of the prices within different bins of the bedrooms. And I just cut it off to any bedroom that was 7 or more. I'm not plotting it just because most houses don't have 7 or more bedrooms. In fact, most houses don't have 5, but whatever. I just let those in. So we see here, like, we have a lot of outliers for 5 and 6, which we might want to go and cut them out, right? We now know we have outliers here. We can start deciding what to do with them. We have a weird outlier right there for the 2 bedrooms, but for the most part, the data is pretty dense in this area. And this is just a nice visualization to get density. So that's why I like to use these. I think we can even change the transparency, but I've never tried it. So if it messes up, I apologize. Yeah, so if you just increase your transparency or decrease your alpha, you can now, like, actually view density a little bit better because they're not all opaque right there. And this is really good. You can also use a violin plot. People tend to really like violin plots just because they're really pretty. And a violin plot basically is just doing like a distribution plot across all the bedrooms, and it's kind of like inverting it and making it symmetrical. And we can do this right there. Okay. And then you can compare them, and we see, like, these big outliers are causing this skewness. And then you can also do a box-in plot, which I just recently found out about in Seaborn. They're pretty cool. And it's kind of like a violin plot, but a little bit, I think, easier to interpret for someone who's never seen these kind of, it's like a box and whisker plot. And so, like, if I was presenting this, I wouldn't just put this in front of somebody. I would probably annotate it and, like, notice that these median lines are increasing as bedrooms increases, which should make sense because houses with more bedrooms probably cost more money, right? So this is good. This is following good intuition. We're not seeing anything super weird. Any questions so far? So I just wanted to show you some visualization tools. You can also do line plots, which are cool. And then I'll show you Plotly as well, because what I love about Plotly is it makes it interactive. So with Plotly, you can actually hover over things and, like, zoom in on different windows and look at various points. And that is very helpful. Unlike this, which is an image, this is a JavaScript. This is like an HTML file. So it's very interactive. We can just reset it. So any questions on this? Comments? I love Plotly. It's amazing. It takes a while to learn. I think they also have Plotly in different languages now. So they have it in JavaScript for sure, because it's like HTML. So you can use a lot of JavaScript, and I think they have like like you can, it's supportive in JavaScript. And then, you know, you can use scatter plots really well. And what's cool about Seaborn, so if you're like an analyst or you want to start analyzing data, is you can set a hue. And so I basically plotted bedrooms versus bathrooms, and the colors are based on the price. So as the colors get darker, the home's more expensive, and as the colors are lighter, the homes are cheaper. And so this is pretty much making sense, right? I would assume that as our bedrooms increase and our bathrooms increase, our price increases. So we should be seeing the darker colors in the corner, like up in the corner of this plot. But we do see some darker homes around here. And so these might be homes that are like on the waterfront, or maybe like have a high condition number or something. All right. And then of course you can plot, we have that lat lawn, we could plot that as well. And we noticed that like, so this is actually a lake in the Kings County area of Seattle, Washington. And we see more expensive homes around it because they're living by a lake, which is really nice. Same thing here, we have some water here as well. We see some expensive homes. So, and then right there. So a lot of what you're doing as a data scientist is this. You're like building graphs and you're getting a feel of, all I'm doing is trying to get a feel of what my data is doing, right? Like
I assume you can also change your opacity there, right? So where they're overlapping, or maybe change the size of the.
Yeah, so you can increase your opacity. Where'd it go? Right there. I think it was decreased pretty far. And then, yeah, you can change the color. You can also change the sizes as well. That gets a little complicated in Seaborn, unfortunately. It's not as easy as Matplotlib, but you could totally do it. All right, so let's say we've gotten a feel for the data and we want to start making models. Some best practices with your models are you want to validate them. You want to cross-validate. I'll talk about what that means. You want to do train test splits whenever you're making models. And if your model has really strict assumptions like linear regression, you have to meet the assumptions. There's no ifs, ands, or buts with linear regression. It has very specific statistical assumptions that if you do not meet it, your model is completely useless. And so you can't do that. Ooh, I just got a great question in the private chat. This might be a question for later, but does the distribution of the data affect what model or method or analysis you use? Yes, 100% it does, because different models do better in different times, and you're actually going to see that in a little bit. Okay, so I'll show you that here in a little bit. Now, all these models I built, I call them Betty Crocker style. They're just out of the box. I didn't do anything to them. So they're going to perform pretty badly, but that's okay. So the first workflow thing that you usually do when you start making models is you just divide your data into your features, which is what we call them, basically like the data we are using to predict, and our target, which is the thing we are predicting. And typically we call them X and Y. So notice here, I just dropped columns that I didn't think were going to be very helpful. We don't need zip code. We don't need actual zip code numbers. Maybe the zip code is a great predictor, but the number itself, that 5-digit number, is meaningless, right? It doesn't have any numerical meaning. It's just a location-based thing. So we would want to transform that into a number that could actually have some meaning to it. That's really important. Like the number itself is 5 digits long. It's like 77777, right? Let's just say it's that.
Based on your scatter plot of lat long, why would you drop waterfront?
Just because there's not a lot of them. There's only like 200 of them. And so I just dropped them for now. So I'm only predicting housing prices that are not on the waterfront. And then you can treat those differently because there's only like 200 of them, I think. And that is because there's not a lot of data, it can, there's only 145 out of your 21,000. And I don't
want to heavily skew your model.
Yeah, it can skew your model. It can cause weird outlier problems. It can bias your model in weird ways. Like, I just get rid of it, which you don't have to, right? These are all my decisions that I have to live with, right? And I have to experiment with. If you're doing this, you do whatever you want. You just need to like understand what you're doing and the impact it could have so you can investigate it later, right? Like, that's the most important thing. It is really an art form. Like, there's an art to this, and I really mean that. So stats models is a great way to build an ordinary least squares or a linear regression model. So I just built one here. And most students, the first thing they do is they look at their R squared and they're like, 0.88, yes, this is great. This model's trash because we didn't meet any assumptions of linear regression. Just want to put that out there real quick. So what I love about stats models is it gives you an entire breakdown. I teach this entire breakdown, how to interpret this. We don't have time to do that. It takes a long time to really like understand all the aspects of it if you've never seen it before. But you can basically use all of these values to get a feel of how good your model is. And even this is telling us like we have issues with our data. And so that's another good thing about stats models is it'll just tell you like, hey, this is not good. You need to go fix something, which is helpful. So this is an OLS using stats models. Most of the time we build models for machine learning, we're doing scikit-learn. And the first thing we need to do is a train test split. So, whenever I talk about basics of data science, this is a huge one, right? You want to build a model on some of your data, on like maybe 70% of your data, maybe more, 80, 85, 90 in some cases. It just depends on the problem you're solving. You need to check out different train test split ratios. But you want to build your model off 70% of your data, and you want to test it on the other 30% that it has never seen, right? Can I predict this data well that it's never seen before? That's what a train test split is for. You don't want to build it on this data and then predict it on this data because it's built for that data, right? It's made to predict that data. It can do that data well. What you want to do is how can it predict on data it's never seen before? So that's why we do train test splits in data science. This is a huge, important piece of it. So what languages do you have to know before getting into data science? I think the language that's most popular is Python. And the benefit of that is Python is really easy to learn. It is like English. If you've ever, is anyone here a C coder or Java? React, does anyone do React? Yeah. Python's like reading English. If you've ever just jumped into the world of Python, it is literally, I think it's the easiest language to learn for anyone. If I have a friend who's like, hey, I just want to learn how to start coding, learn Python.
It's also one of the most efficient. Like with React, you have all this extra code to do one thing. So with C, you have like a ton of code to do one thing. In Python, one line of code does 10 things.
Yeah, that's very true. Yeah. Python is great. Some people don't like it because it's so easy to use. Like there's this weird elitist attitude around it. You can have that. I guess I don't think that's good, but whatever. I think if a language is easy to use, that's great, right? More people can get into code, and that's what I want for people.
Rafael?
Yes.
Along the lines of the programming, it seems like, I understand that probably a large percentage of the time you're just doing kind of tedious data cleansing, and things like that. Mm-hmm. And only, I think 10% is even low for communicating because it seems like most times I've interacted with people doing data analysis, it's really a lot about going back and tweaking a little bit and coming back and discussing again. But how much of your curriculum is really about programming, and how much of it is really just learning the different aspects of a few different tools? Because my other experiences being at IBM, they always had a tool set and they pretty much used what they used. So I know that there's always new tools coming, but I was just curious in the curriculum, is it how much of it is programming and how much of it is essentially, learning the different tools and just some subset of tools that might be used at a particular company?
Yeah, I think we teach a lot about the statistics and the mathematics behind everything,
Okay.
and then Python is the way to drive that and communicate that like to the computer, so you can actually get something working. Um, and then we do teach how to build workflows in, so using Python to like build a pipeline where you can just pass in data and it kind of is automatically going through this cleaning pipeline and modeling pipeline, so you can just keep passing it in over and over. But then one thing that we all stress is like you have like we really teach our students how to learn, because this will be obsolete at some point. That is just the reality. And so if you don't know how to learn new things, that's not good. You can't just rest on what you know. And you always have to learn new things. And so I feel like the benefit of a boot camp is it's literally the experience of learning something new all the time. If you ever has anyone ever done a boot camp? It's intense. I did a boot camp, and it's just something new every day. And I think that
Yeah, I also did a boot camp. I have one more day left for the boot camp, and then yeah,
oh cool.
on online.
Yeah. So but yeah, I think I'm very transparent with my students. Like this could be obsolete in 5 years, so you need to be able to pick up new frameworks, new libraries, and just begin coding. And because they're in a boot camp, they have to learn how to learn, because it's what you're doing every day. You're learning something different. And you kind of can't get away from that reality. Any other questions? That was a great question. All right. So we can use scikit-learn to just train, test, split our data. And I just wrote here a function that takes in a model and it will fit the model. So this like fits the model on the training data. This will get the score of the training data, score of the testing data, and then it'll print those scores. And I just built a linear regression model, a random forest, and a k-nearest neighbors. I'm going to talk about the KNN in a little bit. And it just spit out the scores right here. So when you're a data scientist, like one thing, whenever I'm looking at this, I'm trying to see how close these two scores are. I'm not looking at how high they are. The first thing I look at is, are they close? Did my model predict the thing it was trained on and the thing it wasn't trained on similarly? Because if it didn't, your model sucks. It's not good. You got to fix it. It's just, it's either overfitting or underfitting, but your model needs to predict things similarly. So this is good. It's at least similar, right? It may not be good, but it's at least similar. This looks good. Oh, we got a 97, but we got an 85 on things. So the thing it was built on, it did really well on. Anything else, it's doing way worse on. And that means it's biased towards what it was trained on, right? And same thing here, it's much higher here than on the training than it is the testing. So this is a sign of overfitting. You want your scores to be really close together. And so the k-nearest neighbors model is a really interesting model. And what it's doing, like if I could just look up a diagram on KNN just to show you an image. What I love about it is it's literally, it takes in a new point and it just says, hey, who are the nearest things around it? let's use those housing prices to predict the housing price of this point that we have. So which houses are near it in our data space? Okay, what are the prices of those homes? All right, let's predict this price using the prices of those homes. I mean, that's literally what it's doing. And so what really matters on KNN is that your data, the space of your data is similar. It's scaled the same, right? We have number of bedrooms and we have square foot living. Number of bedrooms is like 1 through 10. Square foot living is in the thousands. So what we want to do is scale that down so the scale is all the same. And so, and this is where knowing math and statistics is important. So I built a standard scalar, and I, I fit the scalar, and then I just transformed our data into this X-train scaled. And we can look at the differences here. So the number of bedrooms went from 3 to negative 0.4 because it got scaled. It used some kind of scaling transformation. Square foot living was 1720, and it's now negative 0.39. So these numbers now are lying within the same scale of numbers, which means something like a KNN, which depends on mathematical distance, will perform better. And when I actually use a KNN, we can look at our two scores here. The accuracy went up a ton. It went from 0.66 and 0.49 to 0.85 and 0.76 just from scaling the data. Now it's still bad, right? It's still overfitting, but we've at least gotten it to like be more accurate. And I just wanted to like show you that because that comes from me understanding how this model works and how I can transform my data to get it to work better with a certain type of model. And that's a lot of the art. Like, how does a model work? How can I get my data to work with it? So that's it. I'm gonna go ahead and stop there. We have time. I'm sorry that I went over, but are there any questions over anything in data science? These are just some big basics. And I wanted to walk you through kind of how we go through problems.
Rafael, I do have a couple that came through private chat. One of them was asking, hold on one second, let me see if I could find it because it was a longer one.
While she's looking, can I just ask real quick, what are some of your favorite reference materials?
I follow Towards Data Science. That's a really good blog on Medium that I follow. I also follow like Jan LeCun. I follow specific data scientists. Jan LeCun is one. Lex Fridman has an AI podcast that I follow and watches interviews all the time. That's another huge one. And then just reading journals and papers as much as I can.
Awesome. Thanks, man.
Yeah. Good question, Todd. I found it. So it was they were asking for a data science to be successful. Do you have to be better or worse at either statistics or software engineering? Like, which one's more important?
I think it's based on environment. A great like phrase that people use as a data scientist is someone who is a better software engineer than the best statistician, and a better statistician than the best software engineer. So like you have to be good enough at both, but it just depends. Like some places it's really code heavy and it's big on software engineering. Some places, if you're doing, like I did a natural language processing research, that was really built on me understanding not even statistics, like NLP, which is something totally different. So it really, unfortunately right now it is case by case. And I would say looking at those job descriptions and in those job descriptions, looking at what tools they're wanting you to use. If you're noticing a lot of big data tools, you're probably going to be doing a lot of coding. If you're noticing a lot of statistical tools like R, you're probably going to be doing a lot of research. And so that's like a good way to delineate that in a JD or a job description.
Perfect. And I've got two more questions here. Both of them are in regards, I think, to more of like hiring and actual like being in the workplace setting. But the first one was, what are some of the most common industries that hire for data scientists?
yeah, I think right now we're seeing a surge of um, big data because everyone's moving to clouds. And so you're going to see a lot of data engineering. Like data engineers are really popular, which data engineering is different than data science, but it's also kind of like it's in a Venn diagram. There is some overlap. But the banking industry, finance industry, the credit industry, um, real estate, agricultural tech is a big one as well. Education, right? There's a lot of people who go into academia as like an analyst or a data scientist. Um, you do lose pay, but it is like really cool experience with research. So those are some big industries I can think of right now.
I think
Cool.
today, I think
Go
with
ahead.
COVID, I think with COVID, health is also a key one right now.
Oh my God, yeah, health. Sorry, thank you. Yeah, the health research. That's a huge one actually. But I think it's also based on the market you're in. Like in Houston, Texas, it's a lot of gas, oil, and health. Those are like the big three ones in Houston. In Dallas, it's a lot of health, credit, banking, and then just like random little smaller companies. So it really like your market's going to be different from city to city. Um, but luckily, remote's becoming more popular now. So. Any other questions?
I had one more that came through chat. If anybody else has, please, feel free to take yourself off mute. The last question I had was about how most data people are structured in the job. They were saying, do a lot of data scientists sit together as a team and then interact with the organization, or do they work with their respective business units directly?
Yeah, so I have seen both. If you're a consultant, you're typically working with a company and meeting with those team leads to work on some project for them. I've done that, and then I've also worked in a little agile space where there was 10 of us all doing different forms of NLP research at the same time, and we all talked together and bounce ideas off each other.
So it sounds like it definitely differs from one job to the next. And that's probably a great question in the interview to ask directly. Yeah.
Yeah, it can really depend. Most of the time, though, you're on a team. If not data scientist, you're on a team dealing with the data, and maybe you might be the data scientist of the team, and someone else might be the data engineer, someone else might be the front end developer. But like, you're usually on an agile team because agile is pretty popular. So.
Okay, perfect. Does anybody else have any questions? Because we are right at time now. I'm actually dropping in a link into the chat as well. Lindsay sent me this just before she had to hop off. She was saying that Flatiron is offering a free data science bootcamp prep course. So I dropped that link there.
Yeah.
But yeah, if anybody else has any questions or any comments or anything, please feel free to ask it now because we're just about to hop off. Rafael, did you have any last minute comments or anything?
Yeah, I want to. I hope this was helpful. This is more technical than what I'm used to doing, but it's a great lean into this. And if you want to connect with me on LinkedIn or you have any questions, just please use that and let me know. I love meeting people and love talking, obviously. So you can just do that. And,
perfect. And thank you. And I did actually early on when you were talking, for anybody that's in here in Zoom, I did drop your LinkedIn page link there. And then Rafael, if you have anything as far as some of the resources that you mentioned, anything that you think maybe any of our audience today may be interested in seeing, or any links, like I'm saying, to anything on Flatiron's page, if you want to email me that, I'll make sure to get that out to everybody that RSVP'd today through Eventbrite.
Great, awesome. I will try and put this notebook up so y'all can see it if y'all want. And
yeah, that'd be awesome.
Get that as well.
Okay, perfect.
All right.
Well, thank you, everybody. I appreciate it. And hopefully everybody has a wonderful day today.
Bye, everyone.
Thanks.
Bye.
Good. Thanks, Laura.
Bye.